problems number 83 and 84. 83 tells us, I lost it again, sorry. Every time I touch the screen, it goes away. $7,000 is invested in an account at interest rate R, compounded continuously. We want to find the time it takes the account to double. So we're looking for an expression. Oh, it gives R. R is 0.02. So 2% interest rate. Recall, I think we did talk about this before we left last month, but the equation, the formula for continuously compounded interest is A of t equals the original amount we invested times e raised to the RT, where R is written as a decimal. So here, we're going to take $7,000. Oops. Sorry. A of t for this function is going to be $7,000 times e raised to the 0.02t. And if we want to know how long it's going to take to double, then we are going to plug in $14,000 for the A of t. We divide both sides by 7,000, and 14,000 divided by 7,000 is 2. So 2 equals 0.0 e to the 0.02t. Now we convert to logarithmic form. Recall our first lessons we did on logarithms were in the classroom. If we had log base b of a equals x, then that means b to the x equals a. If we can convert from logarithmic form to exponential form, we can convert back from exponential form to logarithmic form. So we say the base is the log, base of the log. What's on the outside of the equation goes to the inside of the log, and the exponent comes down on the outside. So here, this is going to be ln, because ln is log base e, of 2 equals the exponent, 0.02t. So if we divide both sides by 0.02, we get ln 2 divided by 0.02. Recall from our classroom discussions, this is not inside the log. This is the time it's going to take the investment to double. And we type that in a calculator. We get ln 2, remember to close parentheses there, then divide by your 0.02. It'll give you a completely different answer or a wrong answer if you keep the division by 0.02 inside. This equals 34.658 years. So, I lost it again. That's not one of the answers. That is the answer. ln 2 divided by 0.02. That's not one of the answer choices, but that is the correct answer. That happens sometimes. Y'all have seen me do it. The next question's number 84. Says which of the following investments will pay the most interest? 11.2% compounded quarterly, 11.4% compounded semi-annually, or 11.0% compounded continuously. To figure this out, we already know the continuously compounded interest formula. We did it in the last problem. Recall, again from our classroom discussion, that the compound interest formula, when it's not compounded continuously, is A of t equals A naught times 1 plus r divided by n raised to the n times t, where n is the number of compounding periods, r is the interest rate as a decimal, t is the time, A naught is the original investment, and A of t is the amount after time t. So here, n equals 4, and r equals 0.112. Here, n equals 2, compounded twice a year, and r equals 0.114. And of course here, there is no n because there's no n in the continuously compounded formula, and r is 0.11. So we're going to do an arbitrary investment. Let's assume A naught is $1,000. So we're going to do the 11.2% interest first, and we take $1,000 for our initial amount times 1 plus 0.112 over 4, that's the n, raised to the 4 times t. We can do this since we're trying to figure out how much it's going to pay for an arbitrary amount. We'll just go 1 year for t. Just let t equal 1 year. We'll type that in the calculator for the 11.2% interest. The 11.4, we'll take the initial amount times 1 plus 0.114 over 2 this time, the number of times it's going to compound, times 2. We're still comparing for 1 year, so t is going to be 1. And finally, we'll take the third, the continuously compounded, and plug that into the continuously compounded interest formula. 1,000 is our initial investment, and e to the 0.11 times 1, because we're letting t equal 1. So we'll just compare how much, and whichever one returns the most money, that will be the one that gives the most interest. So we have 1,000 times 1 plus 0.112 divided by 4 raised to the 4th power. And that gives us $1,116.79. And we'll type in the one for semi-annually, 11.4, and we'll get $1,000 times 1 plus 0.114 divided by 2 raised to the 2nd power. Oh, we did something wrong. We multiply it by 2 instead. 1,000 times 1 plus 0.114 divided by 2 raised to the 2nd power. So that's giving us 117.25. That's better than the first one. Now let's look at the continuously compounded interest formula. $1,000. Second ln gives us e to the x power raised to the 0.11. That's times 1, so we can leave it like that. And that gives us $1,116.28. So the semi-annual at 11.4% would give us the most interest. And that is going to be answer B. And that's today's work.